Hello, awesome AP Bio students. This is Mr. Buss. The video that you're watching, this is going to walk you through this 5A probability and genetics worksheet. I'm going to have a few of these this unit kind of to substitute for the fact that we can't be in class, and a lot of these things we probably would have gone through together in class as guided worksheets where I would teach a little bit and then give you a chance to practice what we just learned and then kind of move forward and so on. So a lot of this worksheet here is what I would consider mirroring, very similar to Gen Bio content. We're just going to go through it a little quicker, but the more complicated stuff we'll see in the next few folders. Not to say this isn't difficult because it's new to you, but this is something that I would probably have produced for a general bio class with similar content. So here we go. In genetics, we talk a lot about the chance of an event occurring, like what's the chance of an offspring being a girl or boy, or what's the probability that a certain trait is passed on. And so we'll take a look at that first. It's just that probability is just defined as the chance that an event will occur. This is the formula for it, right? What are you looking for, and how many total events are possible? And then we do have some probability laws in our AP Bio formula sheet. If you picked one of those up in class, or it's in the resources folder. We're either going to, if we have multiple probability events occurring, we either add them together or we multiply them. And it depends on how we're talking about them. And we'll look at these little questions here. So question 1, what is the probability of rolling a 1 on a die, or that's just a singular for dice? Well, that's where we're looking at this number of events of choice over possible events. A die, or dice, if you want to call it that, is just a cube with 6 sides, right? And so the event we're looking for is a 1, and there's only one of those. One side is a 1. And divide that by how many possible sides are there? 6. So that's the probability of rolling a 1 at any given roll. Number 2, what is the probability of rolling 2 dice and getting a 1 on both? Okay, well, the probability of getting a 1 on one of them is 1 out of 6, and the probability of getting 1 on another one is 1 out of 6. Okay, now do we add them together or multiply them? Look at our laws. We're using an and in the statement here, getting a 1 and a 1. So A and B are independent of each other, and we're going to then, if probability of A and B are independent, we will multiply them together. So 1/6 times 1/6 equals. Okay, maybe you haven't multiplied fractions very often, but I'm going to take my 1 times 1 is 1, multiply my numerators, and then 6 times 6 is 36. So there's a 1 in 36 chance of getting snake eyes, it's called. 1s on both of them if you roll 2 dice together. What is the probability of rolling a 1 or a 2? Okay, well, getting a 1 is a 1/6 chance because there's 1, 1. Getting a 2 is 1/6 chance. So these are mutually exclusive of each other. Probability of rolling a 1 or a 2. Okay, so we're going to add them up. So 1/6 plus 1/6 equals 2/6. Or if I reduce it, it equals 1/3. Question 4, what is the probability of flipping a coin 4 times and getting a heads on all 4 times? Well, probability of getting a heads is a half. And I'm doing this 4 times. And I'm getting asking to get a heads and a heads and a heads and a heads. So that means I'm going to multiply them. Because if it's an and statement, then we're going to multiply them together. So 1 times 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 is 8, times 2 is 16. All right, question 5, there's a bag containing a bunch of marbles. Without looking, what is the chance of pulling out a blue marble? Well, what's our equation say? Events of choice goes on top. A blue marble, there's 10 of them. Over what's the total? 40. And then we're going to put that blue marble back, and then we're going to try to get a green one next without looking. Okay, there's 20 greens over 40. And this is a and statement. I'm not saying get a blue marble or a green marble. I'm saying get a blue marble and then getting a green marble. Okay, so multiply them together. All right. I'm going to reduce that. Okay, the next one is similar. Bag contains 40 marbles. What is the chance of pulling a blue or a green? And there's an or statement. So I'm going to add these together. So blue is 10 over 40. And green is 20 over 40. Okay. And lastly, probability before we move on is this idea that there's a deviation. Deviation is how far from expected did you get? You know, so if I flip a coin, I'm expecting to get heads or tails. If I flip the coin a bunch of times, I might not get expected. So what I mean is if I flip a coin 10 times, I might not get exactly 5 heads and 5 tails, which is what is statistically expected. Okay, so let's calculate deviation, which is how far from what you expected the results to be did you actually go. So flip a coin 10 times, and I got 6 heads and 4 tails. What's the deviation? Well, deviation is calculated by the difference between the expected and observed divided by the total numbers of trials. So I flipped a coin 10 times, so statistically I would expect 5 to be heads, and I would expect 5 to be tails. Okay, well I didn't get that. I got 6 heads and 4 tails. So the difference between expected heads is the difference between 6 and 5, and the difference between expected tails is, you know, it's just the difference. So if I took 4 minus 5, it would be -1, but it's absolute value. So it's just difference. So my difference between what I expected and what I observed is 1 and 1. 1 plus 1 is 2. Total number of events, I flipped the coin 10 times. So my deviation is 2/10, or I'll just write it in decimal form, 0.2. What if I flip the coin more, 1,000 times? Well, if I flip a coin 1,000 times, I expect 500 to be heads, and I expect 500 to be tails. Well, I got 520 heads. Well, so the difference between what I expected and what I got, difference between those two numbers is 20. Tails got 480, expected 500. Difference between 480 and 500, 20. So again, difference between expected and observed for both heads and tails, divided by the total number. In this case, it's 1,000 flips. All right. So that'd be 4 over 100, or 0.04. Well, one thing you can notice here is that the deviation going from 10 flips to 1,000 flips, the number got smaller. The deviation got less. Deviation of 0 would be exactly what you expected, like 500 heads and 500 tails. All right, so the more, this is just what happens. The more events, the more times an event occurs, the closer the overall totals will get to what your expected numbers are. All right, so I'm going to pause the video and then I'll restart here and we'll go over the genetics section of it next.